Hi everyone and welcome to this video. In this video we are going to make one mega project where we will be building a system which will generate fashion clothes for us. Maybe if you have seen a data set known as Fashion MNIST, and we will generate the same using generative adversarial networks. This will be our first project in the series of GANS course, and a lot more project and mega project will be coming up on this course. So in this video, the motto of this video is to make your first GAN and make a very good GAN. So very good GAN means you will be building a system that generates the clothes images, okay, using Fashion MNIST. Okay, so I hope that you have already watched my previous video and about GANs and deep learning, so I highly recommend to watch that video and then comment that. But let's start off with this project, and again, project is generation of fashion clothes using vanilla GAN. Okay, so this is our first GAN, so we'll call it the vanilla GAN. Okay, so first of all, I have written all the layers, etc. But first of all, what I will do, I will start by importing the basic library. So I will just import NumPy. I will import NumPy as NP. Then I will import Matplotlib as PLT. Then I will import TensorFlow as TF. And then these are basic libraries that I think that is basic library. So I will just annotate it. So you should be at least if you see this source code, it makes sense. So basic library, which is not that important. Yeah, obviously this is important, but this is a basic library that it should import. Next thing that we will import is optimizers, like if you know about gradient descent. So just like this, we have an atom optimizer that we have to import. Okay, so from TensorFlow.keras.optimizers import atom. Okay, so we'll import atom. So I will give this a name of optimizers, which will be using this atom optimization for optimizing our discriminator model. Okay, so let me write this as optimizers. Okay, I will not take too long this video. I will just try to finish this in short interval of a time. Okay, so the next thing we want to import is some layers that we want. So let's import first of all sequential. So what sequential does, it from TensorFlow.keras import sequential, and what sequential does, sequential stacks up the layers. So let's say we have one layer here, then let's say we have instantiated sequential over here. Okay, so let's say we have instantiated sequential over here. Now if you want to add some more layer, you can simply a.add, and now you can add more layer, then you can again add more layer. So it contains the stack of layers. It helps us to contain the stack of layers. Okay, so that's why we are doing like this. Okay, after that we will import some basic, or maybe the basic or the important layers that we'll be using in this videos. It is from TensorFlow.keras.layers, and I will start importing like dense layer. Then I will import batch normalization. Then I will import maybe the leaky ReLU is also leaky ReLU. Then we can import reshape layer. Then we can import dropout layer. Or either we can use dropout or batch normalization. I will talk about these is the basic. I think this is the basic that we need, and nothing much. Okay, so I think we are this is the basic layers that we need, which is dense layer. Dense layer is the fully connected layer, as I've just showed you, is the fully connected layer, and the batch normalization is a technique to normalize your output from the a previous layer. Okay, so it normalizes your output, because a neural network works best when the data is normalized or your coming data is normalized. Okay, so a leaky value means, let's say leaky value that I just talked you is the activation functions. Then input is the layer which you will get to know just in a second, and reshape is the layer that will reshape our image, and dropout is the layer means it removes the node in the hidden layer which has a which is 0, which does not provide a lot more information to the next layer. Okay, so this is the basic definition of this, and now we have imported these kind of things. Now because I'm talking about each and every layer, because many of the instructors are not teaching it in a very important thing known as the importing libraries, which is one of the important things that I think so that you can understand what to import at the same time, how to think about it. Okay, then I want to import that from TensorFlow.keras.datasets. I will import let's import TensorFlow.keras.datasets. Okay, we will import later on. Okay, so we have made till now, and this is the layers. This is a let me write important layers, important layers. Okay, so we are done with this. Now we have imported our basic libraries that are required. If there is more, we can come here and add some more libraries. Okay, so now it's time for getting into the layers for a discriminator. So this discriminator is a classifier. So I designed a neural network. First we will the data that we'll be using is the fashion MNIST, and the properties it has a 70,000 images of clothes, means shirt, etc., which is a grayscale image, and the size of each image is 28 by 1. So 28 width, height, and the 1 it indicates the number of channels into that. Okay, so this is the similar. We are going to use fashion MNIST. So we are going to train our model to identify, or train our classifier to identify these kind of things. Okay, so I will make one function. Which is build a discriminator, and then it will take the input it will take is image shape. So it will take image shape, and in this case it is 28, 1, and it will also take the summary, means summary equals to true. What does it mean summary equals to true? As it means that which will we want to print the structure of this, which you'll get to know about just after we bring to the output. If you are not understanding what is summary, don't worry. Okay, now we had build discriminator. Now what we will do, that I've just talked about sequential, so we can write sequential where we will stack our layers. Now model.add, and first of all what we have to add, we have to take input. Okay, and input here is the shape, and the shape here is the image shape. Okay, now we have taken the 28 by 28 by 1. Now we can flatten this out. Flattening means 28 times 28 times 1. So this is 74. I think so. I'm correct. So this is 28 times 1, and this is equals to 74. So that's what flattening layer does. Okay, so flattening layer, we are flattening our layer. Okay, flattening our image. Images, and then what we are doing, we are just adding a fully connected layer, and fully connected layer over here is with 512 hidden units. Okay, or you can say the nodes in the particular hidden layer. So this is the hidden layer which is 512 nodes. Okay, pretty much easy. And the reason why I'm telling 512 nodes, it's basis upon your experience. Means you in neural network you have to design your network in such a way, it is a very iterative process. You have to go, then check, then etc. So you have to tune it for getting a good node and it's basis on your experience, how much you are experienced in particular domain. Okay, so now what we can do, and then we can add a leaky value, because every node is followed by one activation function, so that we can give the output from that activation function. What it does is it scales your output between either in some certain range. In leaky value, it does within 0.3 and 1. Okay, so here we want a negative slope of 0.3. that I have just given an equation. The section number 1 deep learning lecture is the equation is max the negative slope, which is a hyperparameter, times 0. I think this is times 0 comma 1. Okay, so this is the basic, and no, it's a, I'm not remembering the things, but it's a negative slope. Okay, so it's so I hope that you are getting what I'm saying, that leaky value is the activation function which scales your output in a certain range, and you have already seen that every node in a hidden layer contains the activation functions. Okay, can contain activation functions, so that we can pass information covered from this to the another hidden layer. Okay, so with a hyperparameter which is a negative slope of 0.3. Now what we can do, we can add one dense layer. We can add one dense layer with 256 nodes. Okay, in the particular hidden layer, followed by again followed by a leaky value, followed by a leaky value, and leaky value with a negative slope of 0.3. Okay, and we have two hidden layers in this. Now what we can do, we can simply our output will be either real and fake. So it will be only one layer, which will be only one output. So we will a single node is okay for making predictions in GANs. Okay, so this is just a 1. Okay, great. So this will give either it is 0 and 1, or it will give the decision whether the particular is a 0 or etc. Okay, or we can say the probability whether a particular image is real or fake. Okay, now we can followed by we can write over here, followed by activation function, and sigmoid scales your output within 0 and 1, so you can write sigmoid. Okay, and it's okay. Now we are done. Now it's time for returning our model. But before that, I want to just if summary sets to true, we can write model. We can write model dot summary. I will tell you what is summary over here. Okay, model dot summary, and then you return the model. Okay, pretty much easy what I have done. So here it's very easy to understand. First of all, you just imported the libraries, then you are making the discriminator for as a classifier, and then you add some layers over there, and the layers are the input layer, flattening layer, dense layer, leaky value, dense layer, leaky value, and dense layer. And I've already explained for flattening layer just a multiplication, and then dense layer is the flickering layer, or we can say the hidden layer, and then you followed by a leaky value with 0.3 negative slope, then followed by again dense layer, 256 hidden nodes into that, and then again leaky value, then at last it only gives the probability, so it only one node would be perfect for that, and followed by an activation function which is sigmoid, and we have to return this whole architecture, etc. And I will tell you what is a kind of thing what is happening over here. Okay, so I think we are done, and then now we are ready to move on to the generator. Okay, generator is a generator which generates the images for us. Okay, so let's write a function for that generator. It will take a z dimension, and z dimension is simply the dimension of your vector, the dimension of your z vector, which is a noise vector, and output shape is 28, 28, 1, because your generator should generate the output which is 28, 28, 1. Okay, which is the, I think, height, width, and number of channels. Okay, then what you after output shape, you have to give summary equals to true. Okay, and summary which will again give you the architecture of this. Okay, now what you have to do, you have to simply, again the same thing, you have to first instantiate your sequential. So you can put sequential, all the layers into that, model dot add. Then you can add some input layer, which determines what input that you're going to get, which is the shape will be equals to the z dimension, because the z dimension will be the shape of this. Then you have to model dot add, then followed by a fully contained layer or a dense layer, which is a 256. Okay, and then followed by a leaky value, with a negative slope of 0.3. Then you add batch normalization, and batch normalization which normalizes your data, which we'll talk about in detail in our next tutorial, which is DC GAN. Okay, batch normal is 0.8 with a momentum of 0.8. Don't write momentum. Okay. Okay, so why we're writing momentum? Because if it will give obviously error, because it's first argument in the axis. Okay, let's leave that default, and we'll talk about more about batch normalization in our later videos or in the next video. We can put dropout over there also. You can put dropout over there for getting more intuitive idea about that. Okay, then you can add simply after batch normalization, you can add again a dense layer with 512 nodes. Then you can add some leaky value. Then you can add some leaky value followed by a leaky value with again negative slope of this. Then you can add again the batch normalization with momentum to be equals to 0.8. And then after that you can add a dense layer, which is 1024. Oops. 1024, and then you can add model dot add followed by leaky value. Okay, with 0.3 negative slope. Oops. 0.3 negative slope. And then what you can do, you can add again the last batch normalization with the momentum equals to 0.8. Okay, that's great. Now what we can do, we can reshape our output, or I can say the last layer will be the dense layer with 784 nodes, or I can say np dot product of output shape. Okay, 28 times 28 times 1. Great. Okay, then what we can give, we can add a activation function, which is a tannage. In this case it is a tannage. Okay, then at last we can reshape our model to be 28 times 1. Reshape our model to be output shape. Okay, so we have designed our neural network, and this is a whole neural network, and I hope that you really enjoying making this whole coding it and making a full neural network. Okay, now what we can do, we can, if summary is true, then you can return your model. Then you can return your return model dot summary, and then you can return your model. Okay, I think it's okay. Now what we can do, we can instantiate, and let me show you what the first image of what build generator will generate from that z dimensions. I've written first of all, I've instantiated this generator, and then I've generated some noise vector z with 100 dimensions, and generated image. We are using generator to generate with training equals to false, obviously. Then we are plt.im show. So let's save this and run this. Let's see what error it will give. You can see over here what the summary will do over here. You can see over here that this summary, what I'm saying, it is giving the network architecture of this neural network. So you can see over here, we started with the dense layer, 256, then this, then a none here, whatever image you can put over here, okay, and with a number of trainable parameters, then batch norm, etc., etc., etc. So matplotlib has no attribute known as I am a show. In that case, I don't know why it is as plt. Okay, so we can write I forgot dot pyplot as plt. Okay, let's see again, and let's see what our output should look like. Okay, so the matplotlib haven't shown us the image. This is why, because of maybe there's some this sublime text, but you can also try in Colab whatever you're using. I've just for fun purposes. Okay, you can try Colab or Jupyter Notebook, whatever you are comfortable in. You can see over here that this is 28 by 28 pixels, and its first epoch generates the noise vector C with this. Okay, now it will make a better and will generate a very realistic images. Okay, so now we are good to go. Now what we can do, we can simply head over to the training part. Okay, so I can simply make it a little bit more comment down. So we'll comment it. Okay, so now it's time for making the training our model. So I've written some here that first we'll load the data, then normalize it, then we'll real and fake, then we'll train it, then we'll take out some random images, then noise generation, then we will take out a discriminator loss on the fake and a real, and then we again take out a noise, and then using the training generator to improve the GAN generator. So you will use a GAN to improve the generator, which we'll see in just after some. As we go further. Okay, so let's start off training, and it will take a generator which let's give as a none, and it will take discriminator which will let's take as a none, and GAN model GAN model which is again we will take as a none, and epochs, let's say 1000 epochs. Okay, batch size, let's say 128, and then you have a Z dimension, let's say 100 dimensional, 100, and then sample interval equals to 200. Means after 200 epochs we have to print the images, that is predict the image with generator how it is doing, it is good or not. Okay, so first of all what we have to do, we have to generate some we have to load our data. So first of all xtrain, we have to generate some, and then this one, this is xtrain, ytrain, xtest, ytrain, ytest. Okay, now you can data sets dot fashion mnist. I can use fashion mnist for this. Okay, now we can normalize our training data xtrain divided by 127.5 minus, I think it's time for making the labels of real and the fake y. Okay, so first of all I will make a real y equals to np dot once, because real is, let's say, once with the batch size and the Z dimension. Okay, and the fake y np dot zeros. Why we are taking Z dimensions? Batch size. Okay, so it's the thing, and we are loaded, and we have made a labels. Okay, it's a little bit more intimidating, but no worries. It's very easy to understand as we go practice further. Okay, for I in range epochs, and you will do for maybe the 1000 epochs over here, and then first of all you will generate some random noise. So no, you have to generate some examples. Okay, generate some the same images from that. You can write that like that. Means let's say first of all. Okay, now we have generated some real examples. Now it's time for after we train, and then we will train. Okay, so now we can generate some discriminator loss and discriminator loss on fake example, discriminator loss on real example. Okay, disk loss fake discriminator dot train on batch real images and real y, and discriminator is a loss fake with discriminator dot train on batch real images and fake y. Okay, so now we can add it all up for total discriminator total loss. Total, let me write total discriminator loss. We can write it now. Oops. Discriminator loss, we can write it like this. What's the timing? Oh, it's fake. Okay. Now we are done with this. Now we have taken a discriminator loss, means the loss, the classification error that I've just shown to you. And now it's time for generating some random noise. So how do we generate some random noise? We have generated random noise over here. Let me show it to you. On batch size z dimension. Okay, and I can write fake images generator dot predict. This is a noise. Okay, great. But here with as we are taking for on fake loss. Okay, so we can do like this. Okay, and we are just discriminator to improve generator. Okay, so we can write gen loss GAN model dot train on batch. We can train on noise and fake images that we have seen over there. Now, so now we are done, but it might feel that here what are you doing this and we are not getting it. You are using your trained discriminator for training on batch. So you have a GAN model which will make just in a second, which we have compiled discriminator over there and stack up into the GAN model whole discriminator and the generator. So you will get to know about this. This will be clear. If it is not clear, don't worry. If you have understood discriminator and the generator, you are good to go. But in the next video, when we'll make DC GAN, it will be more clear, because it is a vanilla GAN. I can't introduce new concept over here like the checkpoints, etc. It should be in our next tutorial. Okay, so now what we can do, we can add just two lines of code that I'm just going to copy from because it's very kind of we are just printing the discriminator and generator loss in some more formatted way, and I have to preserve my time also. Okay, training update and etc. And it's just discriminator loss, and we are just discriminator loss 100 times the discriminator loss and the generator loss. Okay, for showing us the training. Okay, so I have just written it out, and we have just enchanted above. We have to do it again, and z dimension, then input shape, then you are just outputting from the generator from this noise that I've just shown to you above. Then you fix the discriminator. You don't want to discriminator to be trained again because it already have been compiled. We will do compilation later on, but it's already have been compiled. And then we take out a validity, that what is the probability of this. Obviously this image will be fake, but what is the probability? So we are taking the validity from the discriminator output, and then you stack the discriminator on the top of generator. So this you are using model, so you can simply you can import in place of model. Okay, you can do this. Okay, so you can just model, then you compile it using binary cross entropy, then you optimizer with the same learning rates, etc. Then you summary of the GAN model of these stacked up layers. Okay, and then you call your favorite function over here, this train, with a giving generator discriminator this GAN model, epochs 30,000, batch size 32, sample interval 200. Okay, now I hope that you had got a little bit intuition about that training function, and I hope that you had really enjoyed this. Now I think it will give some error. Let's debug it a little bit. Inconsistent use of tabs or indentation. So that's the problem arises. Again, what's the problem? Is there inconsistent use of tabs? Okay, so it is telling to do not use like that. Let me do this kind of thing. Okay, I think it will work now. Let's save it. Let's run it. Inconsistent use of tabs. Again, we have done it correctly. No, we have done it correctly. Percentage. Either I don't know, this error is not given on the inconsistent use of tabs. Okay, fixed. And I have also given the thing over here. You can see over here I have also given the simply the comment so that you can get to know it better. And the same thing is here. It was happening with some the debugged and some indentation. But what happens, one more error, and one more error is we don't have a flatten layer. So let's do the flatten also. Let's import the flatten. Let's compile it again. Control B. I'm pressing Control B for this. Activation is got an unexpected arguments. I think I have done it again wrong. I have to put this activation over into the dense layer. It happens me around, I think it's second time. I think so. It's second time. Yeah. Let me run it again. Let's see. I hope that it works correctly. Data sets and not defined. Hey, I have imported data sets, so let's import data sets. So let me import data sets from Keras. Let's run it. Okay. Now you're seeing that it first gives the generator sample images. Okay. So one more util functions that I'm not going to define. I've taken from GitHub, forked it. So I'm just going to put it over here just in a second. Okay. So here is my utils. So I can simply import. Utils. I can import utils. Utils, and from utils I can import sample images. Okay, and sample images I've taken from GitHub. Sample, it's just to print your images. Okay, you can have a look. It's very easy. Okay, you can have a look at that if you want. Now let's run. No module named utils. I don't know why, but I have my utils. Let me make one more. Let me copy this over at last. After this. I think utils is on my another folder. No worries. We can have a look now. I hope that it will run correctly. Okay, great. Now you can see over here at this loss. Now it is being trained. Now we'll wait for some more minutes. But I would highly recommend to run this whole 30,000 and then you will see magic. Magic is simply very good magic will happen. I will just show you, and please kind of run in Colab and whatever you have when you run that. And one images has been shaved. So let me go to that pictures, and we have a GANS, and in that images, I don't know. Yeah, here it is. The images are being saved, but here because of maybe some settings it's not being, but for now I'm just canceling it out. I don't know how to cancel. I'm pressing Control C, but it's not being canceled. I don't know why, but you can. I'm just going to delete this, but let me show you how does it generates after 30,000 epochs. Okay, so I'm just going to go into drive.google.com because I was training on Colab.Jupyter notebook. Okay, so I will just go to there and I will click on resend, and I will click on over and over, and you can see over here after this is to start generating like this. Okay, and it's very beautiful to see these kind of things, that these technologies is doing these kind of tough things. And again, we'll be making an image like this. Let me show it to you if I can, like this images, and like this image, this real world image using GANS. We will definitely do that, and I hope that you will enjoy that also. This is the first step towards the GANS, and it's a very important to take a first step in any domain, and I hope that you really liked this tutorial. Okay, now maybe some of the problem is over here, maybe in that. Don't worry, it's very easy. You can understand by your own. It's kind of easy to understand what I was doing, and we have coded it along, and I really enjoyed that, and I really hope that you all have enjoyed. And thank you for seeing this video. Please be sure to subscribe this YouTube channel, because it takes a lot of time for making these kind of videos and keeping efforts for you all. Okay, so I will catch you on the next video. Till then, bye bye.